For almost a century, Pluto was treated like a mistake at the edge of the solar system. Too small to matter, too distant to understand, too frozen to be alive. It was discovered, celebrated as the ninth planet, printed in textbooks, and placed on classroom walls. Then, in 2006, it was stripped of its title by a vote. After that, Pluto became something between a world and a footnote, a cold leftover drifting in the dark beyond Neptune. But then the James Webb Space Telescope looked at it, not the way New Horizons did, racing past in a single historic flyby. Webb didn't give us another portrait. It gave us something stranger. A chemical fingerprint, a temperature clue, a hidden atmospheric signal. Evidence that Pluto is not simply frozen. It is active. Its haze is cooling it. Its atmosphere is leaking. Its moon is being stained by stolen gas. Its surface is covered in organic chemistry. Its mountains may be ancient cryovolcanoes. And beneath its shell, there may be a dark ocean buried under miles of frozen, rock-hard ice. Pluto is not dead. It is colder than death, darker than almost anything we can imagine, and yet somehow still changing. And what Webb found out there is horrifying because it means the far edge of the solar system is not empty. It is full of frozen worlds doing strange things in silence. Pluto was not the ending of the planetary story. It may have been the warning. When Clyde Tombaugh discovered Pluto in 1930, he was only 24 years old. He had no college degree. He worked night after night, comparing photographic plates, searching for one tiny dot that shifted against the fixed background of stars. When he found it, the world believed it had gained a ninth planet. But for most of the next 75 years, Pluto remained almost unknowable. It was too far away to resolve clearly, too small to reveal much detail, and too strange to fit comfortably with the larger planets. Its orbit was tilted and stretched, carrying it inside Neptune's orbit for part of its journey before flinging it billions of miles farther into the cold. From Earth, Pluto was not a world. It was a point, a faint moving speck. So we filled the silence with assumptions. We imagined it as a dead ball of ice, a frozen pebble at the edge of the sun's reach, too small and too cold to be geologically interesting. Then New Horizons arrived in 2015. After 9.5 years of travel, the spacecraft flew past Pluto at incredible speed and changed everything in minutes. It revealed a heart-shaped, bright region across the surface, mountains of water ice as hard as stone, plains of nitrogen ice that seemed to flow, and a thin blue haze layered high above the dwarf planet. Pluto was not smooth. It was not simple. It was not dead. It had geology. It had an atmosphere. It had movement. It had surface features that looked shockingly young. And because New Horizons only had one fast flyby, scientists were left with a haunting question: what else did we miss? That is where James Webb entered the story. Webb couldn't fly back to Pluto, but it could stare at Pluto from deep space and read its light with extraordinary precision. It could detect molecules, thermal behavior, and atmospheric chemistry that no telescope before it could measure in the same way. And when Webb looked, it revealed that Pluto was not just unexpectedly active. It was stranger, colder, and more disturbing than anyone realized. The first horror of Pluto is its atmosphere. It barely has one compared with Earth. Pluto's air is incredibly thin, made mostly of nitrogen with methane and carbon monoxide mixed in. It is so faint that standing on Pluto would feel almost like standing in a vacuum. And yet that fragile atmosphere is doing something bizarre. It is wrapped in layers of haze made from complex hydrocarbon particles, created when faint sunlight strikes methane high above the surface. Even at Pluto's distance, where sunlight is about 1,000 times weaker than on Earth, the chemistry does not stop. Methane breaks apart. Molecules recombine. Heavier compounds form and begin drifting downward. For years, scientists wondered what these hazes did to Pluto's atmosphere. On worlds like Titan, haze helps trap heat. But Pluto appears to work differently. Its haze is cooling the atmosphere. The particles absorb sunlight and then radiate energy away in the mid-infrared, bleeding heat into space faster than the atmosphere can replace it. In other words, Pluto's own haze is helping chill the world beneath it. A frozen planet cooling itself even further. That is almost impossible to picture. Pluto already lives in a realm of cold beyond human experience. Its surface temperatures hover hundreds of degrees below 0 Fahrenheit. Nitrogen becomes frost. Methane becomes ice. Carbon monoxide can fall as crystals. The gases that make Earth breathable become part of Pluto's frozen ground. And above that ground, the atmosphere is slowly manufacturing organic molecules: ethane, acetylene, ethylene, tholins. Those reddish-brown compounds fall back toward the surface like an ancient chemical snow. They coat the landscape, stain the ice, and accumulate over geological time. The disturbing part is what they resemble. Tholins belong to the same broad class of organic chemistry that scientists believe may have contributed to the early chemical pathways on Earth before life emerged. On Pluto, the raw ingredients of biology are being produced constantly, then frozen into silence before they can become anything alive. It is life's chemistry trapped in a world too cold to let it continue. A prebiotic nightmare preserved at the edge of the sun. Then Webb revealed something even stranger. Pluto is leaking. Its weak gravity cannot hold every molecule in its thin atmosphere forever. Methane and other gases drift upward, escape into space, and leave the dwarf planet behind. But they do not simply vanish. Something is catching them. Charon, Pluto's largest moon, orbits close enough to collect part of what Pluto loses. It has no thick atmosphere of its own, no blue haze, no living weather system. It is a battered ice world, locked in a gravitational dance with Pluto, always showing the same face across the emptiness between them. And yet Charon's poles are stained a deep reddish-brown. For years, scientists suspected the color came from Pluto. Webb helped confirm the terrifying mechanism. Methane escaping from Pluto's atmosphere travels across the space between the two worlds, freezes onto Charon's polar regions, and is then transformed by sunlight and cosmic radiation into heavier organic compounds. Pluto's atmosphere is being stolen, processed, and painted onto its moon. This is not just erosion. It is not just atmospheric escape. It is a slow, silent exchange between two frozen bodies. Pluto is bleeding into Charon, and Charon is wearing the stain. There is almost nothing else like it in the solar system. A dwarf planet losing its breath to a moon, while radiation turns that stolen gas into organic darkness at the poles. And Webb found more. Charon's surface contains carbon dioxide and hydrogen peroxide, both frozen in the deep cold. Radiation breaks apart water ice and rearranges the chemistry, creating compounds that would be familiar on Earth but feel alien and poisonous in this context. So the Pluto system is not passive. It is chemical. It is violent in slow motion. A frozen world leaks. A moon receives. Radiation rewrites the atoms. The poles darken. From a distance, Pluto and Charon may look like quiet ice spheres, but up close, they are locked in a billion-year exchange of stolen atmosphere, frozen chemistry, and cosmic radiation. A dead-looking system still doing something deeply alive in the language of molecules. The surface of Pluto may be even more terrifying than its sky. East of Pluto's bright heart lies Tartarus Dorsa, a region filled with enormous, jagged ridges of methane ice. They look like blades lined up in parallel formations, rising hundreds of meters above the surface. On Earth, similar features, called penitents, form in cold, high-altitude deserts, but they are usually small. On Pluto, the structures are monstrous. Some may rise as tall as skyscrapers, forming fields of frozen knives across the equatorial region. Imagine standing there. The sun would be a tiny bright point. The sky would be a dim bluish-gray haze. The ground beneath you would not be soft snow, but water ice frozen so hard it behaves like rock. Methane would form glaciers. Nitrogen would fall as snow. And around you, giant blades of ice would stretch across the landscape like a frozen weapon field. Then there is Cthulhu, a vast dark region near Pluto's equator, reddish-black and ancient, stained by tholins that have accumulated for billions of years. It is like a chemical scar across the dwarf planet, a place where Pluto's long exposure to sunlight, methane, radiation, and time has darkened the surface into something almost burned. And then come the mountains. Wright Mons and Picard Mons rise from Pluto's terrain like possible cryovolcanoes. They have broad bases, central depressions, fractured flanks, and shapes that resemble volcanic structures on Earth. But if they erupted, they did not erupt molten rock. They may have erupted water, ammonia, methane, and slush from beneath the crust. That possibility changes Pluto completely, because cryovolcanoes require internal heat. Something under the surface must have been warm enough, at least at some point, to push liquid or semi-liquid material upward through a crust of frozen ice. And beneath that crust, Pluto may still hide an ocean. A dark, salty ocean buried perhaps 100 miles below the surface, warmed by radioactive decay in the rocky core and sealed beneath a shell of ice harder than stone. If it exists, it could have remained liquid for billions of years. Think about that. At the edge of the solar system, on a world where sunlight is almost powerless, where nitrogen falls like snow and organic chemistry freezes before it can wake up, there may be liquid water hidden in the dark. A buried ocean, a frozen chemistry lab above, a poison moon beside it, a planet that breathes on a 248-year cycle, freezing its own atmosphere onto the ground and releasing it again when it moves closer to the sun. This is not the dead Pluto we imagined. This is a world with layers, cycles, chemistry, geology, and secrets buried deeper than any telescope can see. And the most horrifying possibility is not that Pluto is unique. It is that Pluto may be ordinary. The Kuiper Belt contains countless frozen bodies. Beyond it, the distant Oort cloud may contain trillions more. If Pluto is chemically active, if Pluto may hide an ocean, if Pluto's atmosphere can feed its moon and paint it with organic residue, then other frozen worlds may be doing their own strange experiments in the dark. Pluto may not be the exception. It may be the first warning from a vast population of worlds we barely understand. So why is Pluto horrifying? Not because it is loud, not because it is violent in the way Jupiter is violent, or burning in the way the sun is burning, or catastrophic in the way a black hole is catastrophic. Pluto is horrifying because it is quiet. It is horrifying because for almost a century we thought it was nothing more than a frozen leftover at the edge of the solar system. A small world too distant to matter, too cold to change, too insignificant to deserve its old title. And then we looked closer. New Horizons showed us the face. James Webb showed us the chemistry. And together they revealed that Pluto is not dead. It is operating slowly, silently, in darkness, at temperatures where the gases of Earth become ice. Its atmosphere is not simply floating above it. It is cooling the world below. Its haze is bleeding heat into space. Its sunlight, faint as it is breaking methane apart and rebuilding it into heavier organic molecules. Its sky is manufacturing tholins, reddish-brown compounds related to the chemistry that may have helped prepare early Earth for life. But on Pluto, that chemistry has nowhere to go. It falls. It freezes. It stains the ground. The ingredients of possibility are trapped in a world too cold to let them wake up. And then there is Charon, the moon that hangs above Pluto like a frozen eye, locked forever in the same position, wearing the reddish stain of Pluto's escaping atmosphere. Methane leaves Pluto, crosses the darkness, freezes onto Charon's poles, and is transformed by radiation into organic residue. A planet bleeding into its moon. A moon wearing the scar. A billion-year exchange happening in silence beyond Neptune, where almost no one is watching. That alone would be enough to change how we see the outer solar system. But Pluto goes deeper. Its surface is carved with fields of frozen methane blades, enormous ridges like knives rising from the ice. Its equator is stained by dark, ancient regions where organic material has accumulated for billions of years. Its mountains may be cryovolcanoes, evidence that liquid material once pushed upward from the interior. And far beneath the crust, under a shell of ice harder than stone, there may still be a dark ocean. Liquid water on Pluto, a world so cold that nitrogen falls as snow, may be hiding one of the most important ingredients for habitability beneath its frozen surface. That is the part that should haunt us, because Pluto may not be special, it may be an example. The Kuiper Belt is filled with icy bodies. Beyond that, the Oort cloud may contain trillions more. Most are too far, too faint, and too small for us to study properly. They drift in the dark with almost no sunlight, almost no warmth, and almost no attention from Earth. But if Pluto is active, if Pluto has chemistry, if Pluto may hide an ocean, if Pluto can feed its moon with stolen atmosphere and paint it with organic compounds, then how many other frozen worlds are doing something similar? How many chemical laboratories are operating in the dark? How many buried oceans exist beyond the reach of sunlight? How many worlds have we dismissed as dead simply because they are too far away for us to see clearly? That is why Webb's view of Pluto matters. It did not just reveal one strange dwarf planet. It forced us to rethink the entire outer solar system. The frontier is not empty. The darkness is not still. The graveyard beyond Neptune may be crowded with worlds that breathe, freeze, leak, stain, crack, and hide oceans beneath their frozen shells. Pluto was never the end of the story. It was the first whisper from a region we barely understand. And perhaps the most terrifying thing is this. For most of human history, Pluto was right there, waiting at the edge of our map, doing all of this without us knowing. Cooling itself, bleeding into Charon, making organic chemistry, possibly hiding an ocean. A frozen world in permanent twilight, quietly proving that the solar system is stranger than we ever dared to imagine. James Webb did not make Pluto horrifying. It simply showed us that Pluto had been horrifying all along.